So here we have example 1. So we've got find the first 8 multiples of 6. So whenever we see a question like this, multiples of 6 means any number that divides wholly by 6 to give us a whole number. So in other words, we look at the 6 times table. So we're going to look at the first 8 terms of the 6 times table. So I've wrote those out here. So we've got 1 times 6, 2 times 6, 3 times 6, all the way down to 8 times 6. And these numbers here, these are the multiples of 6. So 6, 12, 18, 24, 30, 36, 42 and 48 all form the first 8 multiples of 6. And that's because if we took any of these numbers, say we picked 42 and we did 42 divided by 6, that would give us 7, which is a whole number. So in order for 42 to be a multiple of 6, when we divide it by 6, it must give us a whole number. So it must divide wholly by 6. And that's how you find the multiples. So if we had, for example, the multiples of 5, that would be anything in the 5 times table. So it could be 10, could be 20, could be 30. It couldn't be 36, for example. So 36 is not a multiple of 5. And that's because 36 divided by 5 does not give us a whole number. And so that means that 36 cannot be a multiple of 5. Whereas 10, 20 and 30, when we divide them by 5, they give us whole numbers. So they can be multiples of 5. So our next example says express 36 as a product of prime factors. So what is a prime factor? So a prime factor is it's a prime number that goes into 36, and when you do 36 divided by that number, it gives you a whole number. So it's similar to the multiple example that we had in the last example. So we're going to use the tree method to do this. So if we put 36 at the top, and we're going to start looking at two numbers that multiply together to give us 36. So if we just start off with the numbers 2 times 18, which gives us 36. So we're going to write 2 on this side and we're going to write 18 on this side. And then we're going to look at whether these numbers are prime numbers. So 2 is a prime number because 2 can only be divided by 1 in itself. So that stays. Is 18 a prime number? 18 is not a prime number. So we start looking at two numbers that can multiply together to give us 18. So maybe we pick 6 and 3 because 6 times 3 gives us 18. So we're going to put 6 and 3 here. Then we look here, are these prime numbers? Well, 3 is a prime number because 3 can only be divided by 3 and 1. So that's a prime number. Is 6 a prime number? No. So we're looking at two numbers that multiply together to give us 6. So we can pick 2 times 3. That gives us 6. So we're going to put 2 and 3 here. And then we're going to look at these prime numbers. Well, these two are both prime numbers. So we stop making the tree now. And we can say that 36 is equal to, we take this 2 times this 2 times this 3 times this 3. In other words, we can say 36 is equal to 2 squared times 3 squared. And that's 36 expressed as a product of its prime factors here. So our next example says find the HCF, or highest common factor, of 36 and 12. So we're going to use that same technique we used in the previous example, that tree method, to find the prime factors. And then we're going to do something else at the end to find the highest common factor between 36 and 12. So what does this really mean? What does HCF really mean? So if we look at the actual definition, so we've got highest, so highest meaning the largest, common, so meaning the same between the two numbers, and the factor. So we're going to look at the biggest number that goes into both of these numbers, and you can divide 36 and 12 by that number to give us a whole number afterwards. So if we start with 36, so if we start off by just doing our tree, so we're going to complete our tree. So we know 36 can divide into 2 and 18. So we looked at this in the last example. That can go into 3 and 6, which can go into 2 and 3. And now we look at 12. So if we start off with 2 again, we can go 2 and 6, and then we can go 2 and 3. So 36 as a product of its prime factors is going to be 2 squared times 3 squared. And 12 is going to be 2 squared times 3. Well, then how do we use this information to find the HCF? So if we write here the HCF, and the way we're going to find the HCF is we're going to look at the numbers that are the same between here and here. So we know that both of these have 2 and both of these have 3. And then we're going to pick the lowest power. So this is 2 squared here, this is 2 squared here, so that's the same. So we're just going to put 2 squared here. This is 3 squared here, and this is 3 here. So 3 is a lower power than 3 squared, so we're going to pick 3. And we know the HCF is going to be 2 squared, which is 4, times by 3, which is 12. And that's the highest common factor between 36 and 12. And that's because when you do 36 divided by 12, that gives us 3. And of course, when we do 12 divided by 12, that gives us 1. So we know that 12 goes into both 36 and 12. And it's the highest number that goes into both 36 and 12. So that's what our HCF is. So here we have example 4. Find the LCM of 3 and 5. Well, what does LCM mean? So LCM means lowest common multiple. So right back in example 1, when we were finding the multiples of a number, so we were finding the multiples of 6 then, we're going to use that same technique to find the answer here. So lowest common multiple means the lowest number that's common between the two, that's a multiple of the two as well. So that'll be, so if we just write out our multiples of 3 and 5, so if we start off with writing our multiples of 3, so we know the multiples of 3 are going to be 3, 6, 9, 12, so basically our 3 times table, 15, 18, and so on. And we're going to write our multiples of 5 now. So we've got 5, 10, 15, 20, 25, and so on and so forth. So this is just our multiples of 5, so our 5 times table. And we're going to look for the lowest number between the two of these lines that's common between them. So i.e. the smallest number that's common between the two multiples. So we can see that 3, 6, 9, 12 are not shared because they don't appear in the 5 times table. 5 and 10 don't appear in the 3 times table. But 15 appears here and it appears here. So this becomes our lowest common multiple between 3 and 5. So LCM of 3 and 5 is 15. And that's our LCM. So we're going to look at another example next where we're going to do an LCM again, but we're going to do it using bigger numbers. So this method is good, but only when the numbers are small. When we're getting into our bigger numbers, we're getting into our 15, 16s and plus, and writing out these multiples is a bit harder because you may not know your 20 times table or your 50 times table. So we're going to look at a technique that's going to allow you to do it even with those bigger numbers. So in our previous example, we looked at finding the LCM of 3 and 5, some fairly small and fairly simple numbers to work with. But now we're going to look at a bit more of a complicated example, so LCM of 12 and 15. So we're going to look at our trees again, and we're going to find the product of prime factors for both 12 and 15, right back we did in our previous example. So if we start with 12, look at two numbers that multiply together to give us 12, so we can pick 2 and 6. This is a prime number, so we leave that. This is not prime, so then we can do this again. 2 and 3. So we know that 12 is equal to 2 times 2 times 3. In other words, this is 2 squared times 3. Now we can do the same for 15. Two numbers that multiply together give us 15 are 3 and 5. So this is prime and this is prime, so we stop here. So in other words, 15 is equal to 3 times 5. And now we're going to look at these. So we're going to look at this, and we're going to look at this, and we're going to pick every single number between the two. So we're going to write LCM here. And we know that there's a 2 here. And even though there's no 2 here, we're still going to write 2 squared down here. So it's not like when we did HCF. For LCM, we're going to pick every single number. So we're going to pick 2 squared. We can see that there's a 3 here and a 3 here. So we're going to pick 3. And even though there's no 5 here, there is a 5 here, so we're going to pick 5. And then we're going to multiply this out. So we've got 2 squared, which is equal to 4, times by 3, times by 5. And that is going to give us a total answer of 4 times 3 is 12, times by 5 gives us 60. So we know the LCM between 12 and 15 is 60. And we can check this because if we do 60 divided by 12, that's going to give us 5. So it's a whole number. So we know that 60 is definitely a multiple of 12. And if we did 60 divided by 15, that's going to give us 4, which is also a whole number. So we know that 60 is definitely a multiple of 15 as well. So the LCM of 12 and 15 is 60. So that's going to be it for today, guys. That was our first lesson on LCM and HCF, so an important topic as a part of GCSE Foundation Maths. Be sure to check back next week for our next lesson.